All right, here we go. So on this paper, this is the one from Monday to start off. Oops. All right, so answers from the homework from the last 2 days. Again, we already went over some of the ones from Monday, but these are the rest of the answers. Now notice, there are some things that have multiple possibilities. So on here, if you look at the questions number 2 and number 5, there are multiple answers when it comes to our lateral area. And the reason why that is because they are rectangular prisms, and in a rectangular prism, it's a little bit harder to identify what you want to use as a base. All right, so they don't tell you what to use as a base. There's actually options because in any prism, the base is going to be the two sides that are parallel and congruent. Looking at a rectangular prism, you have a front and a back that are parallel and congruent. You have a bottom and a top that are parallel and congruent, and then you have two sides that are parallel and congruent. So that's why they give different options, because depending on what you use as the base, that's going to change your lateral area. Because whatever you use as the base, those do not be included in the lateral area, it'll be all the other bases. The surface area is not going to change, and the surface area is all the lateral area plus both base areas together. So on both 2 and 5, the surface area that you got should be the same no matter what you use as a base. Okay, I'm going to read through some of these real quick and check your answers. If you have questions, let me know. So on 1, lateral area was 120, surface area was 132. Number 2, again, the lateral area could have either been 460, 400, or 540, depending on which thing you use as the base. And then the surface area was 700. Again, all these are in square units. I'm not going to read off all the square units just so I can go through it a little bit quicker. On number 3, lateral area was 540, surface area was 663.9. On number 4, lateral area was 588, surface area was 828. On number 5, lateral area was either 128 or 192. Surface area was 224. And then on number 6, lateral area was 384. Surface area was 467.1. Any questions? Yeah. Number 4. Yeah. All right. So number 4. First, what is our base? What shape? Trapezoid. So when we're doing this one, for number 4, we have a base that's a trapezoid. So we're going to do our base formula as 1/2 B1 plus B2 times height. All right. So plugging into that formula, we have all the parts that we need. We have B1 and B2 can be 10 and 20. The height is going to be 8 there in the middle. So multiplying this out, 10 plus 20 is 30. 30 divided by 2 is 15. 15 times 8 is 120. So that's our base area. Now, once you have your base area, you have to find your lateral area and your surface area. So lateral area on this one, we're doing the perimeter of the base times the height of the solid. Well, perimeter of the base, they gave us all the parts of our base. We have 10, we have 20, we have another 10, and we have 9 for a total of 49 for our perimeter. And then our height, again, it's height of the solid, not of the base. So the height this time is going to be 12. So 49 times 12, that's giving us 588. And finally, surface area, we have the lateral area, which we just found was 588. And we have 2 times the area of the base, which is 120. So 120 times 2 is 240. 240 added on to 588 is 828. Yeah, all of our answers are in square units. But since we're in centimeters, all these should have centimeters squared on the end. Any other questions on that side? I think I've done 1, 4, 5, and 6 now during class time. We good? All right, let's go to the next page. All right, so on this one, now we have our cylinders. This was, again, from Monday. We've already done a few of these. I don't remember which one we did. I want to say it was like 1, 5, and 6 again. Again, just reading off correct answers. If you want me to go back and do any of them, let me know. Ladder area for the first one was 301.6. Now, notice most of our numbers are pretty big. When we're dealing with ladder area, surface area, and volume, we're going to get really big numbers. So we have pi that we like to use to multiply on these questions. When we do things with pi, you have different options. The most exact value when you do pi is going to be if you use that pi by calculator, and you do most decimal places. Also, just in general, if you have to round a number, leave extra decimal places so that when you multiply, your final answer doesn't have a whole lot of rounding here, because it said round to the nearest 10. But I would recommend going out 3 or 4 decimals on any number you have to round previous to that. So if your numbers are slightly off, that's okay. It just probably means that you either use something different for pi than the final calculator, or maybe you rounded something a little bit different early on. So like if you had like 300.9 or something like that, that's close. That'd be fine. All right. But just make sure you account for that rounding error. So number 1, again, that 301.6 was the ladder area, surface area was 402.1. Number 2, ladder area was 377, surface area was 603.2. On 3, ladder area was 113.1, surface area was 169.6. On 4, ladder area was 502.7, surface area was 603.2. On 5, ladder area was 150.8, and surface area was 377. And then on the last one, number 6, ladder area was 12.6, and surface area was 37.7. Any of those that you want me to go back to? Like I said, I think we ever did 1, 5, and 6 between the last 2 days. What's you got? 3. All right. On 3. Now they drew in a diameter, but they labeled each part of it separate. So those are the radii that they gave us. So 3 is the length of the radii. All right. And 6, this is going to be our height. So plugging into our formulas, first for lateral area on this one, it is circumference times height, or 2 pi r, which is 3, times our height, which was 6. So again, I plugged into those 2 pieces. 3 times 2 is 6. 6 times 6 is 36. So that's an exact value. And then the rounded answer, when you multiply it out, that would be 113.1. For the surface area, we have the ladder area plus 2 times the base area. So I would have used that exact value first for my ladder area, plus 2 times the area of the base. Well, what is my area of the base? It's pi r squared. So pi, radius is 3, 3 squared. 3 squared is 9. 9 times 2 is 18. So 36 pi plus 18 pi. Again, those are like terms. I can add them. That's going to give me a total of 54 pi. And then once I plug that into the calculator, 54 pi, that's 54 times 3.14, gives me roughly the 169.6. Good. Go on to the next one. On here, now we're looking at volume. Again, in each case, we're looking at the area of the base times the height to get the volume. So You only have one answer for each of these. All these are now in cubic units. So number one was 512 cubic feet. Number two was 9 cubic centimeters. 3 was 467.7 cubic feet. 4 was 1,800 cubic feet. 5 was 27 cubic centimeters. And 6 was 84 cubic yards. Questions? So I think I might only done one or two of those this year. Yeah, I know. Am I? Okay. One? All right, so on one, again, it didn't matter what you use as a base, all the dimensions were the same. So again, volume equals base area times height. Base area on this one is going to be found by doing, if this is our base, it's 8 by 8. And then our height is also 8. So essentially we're just doing 8 times 8 times 8, which is 5. If it is a cube, so all the dimensions I was saying there, you could just say whatever the one length is, cube, and that does give you the correct answer. That's why it's called cube. All right, let's go on to the other one. So the cylinder's volume, number one, we have 12.6 cubic feet, 226.2 cubic feet, 384.8 cubic feet, 4, 6,283.2 cubic feet, 5, 652.4 cubic feet, and 6, 12.6 cubic yards. On number 6, so they're pointing to the radius there, so this is our radius. This is a perpendicular distance between our bases, so this is our height. Those are the only two things that we need in order to do our volume. Our volume, again, is base area times height. For a circle, we are always going to use, for a cylinder, we're always going to use a circle as our base, so that is pi r squared, so that's 1 squared. That's going for the base. And then the height was 4. So 1 squared is 1. 1 times pi is still 3.14. Essentially, we have 3.14 times 4, which gives us the 12.6 cubic yards.
I thought we took the time to outside, so I did it.
All right. So again, whenever you're talking about height for our solid, is always that perpendicular distance between the bases. So this slanted piece between them isn't going to work. All right. We'll, for the next one where we do like volume, cylinders, cones, cones and pyramids. Then we're going to start looking at some of the slanted edges because we will need those. But for this, if we're doing volume, it's always that perpendicular height that we do. So 4 was the piece that you had to use as the height. Anything else? All right, let's go on then. So actually, no. Oh, no, I want this first. Okay. Up at the top of, did I give you the new paper yet? No? Let me pass that out real quick. Yeah. She just asked that. Is there anybody else I missed? All right, then. Let's go ahead and start talking about this. In our shapes that are our pyramid and our cone, they have slanted edges. Right? They also have only one base. They have a vertex at the top. Most of the pieces have similar names. So again, we have a base, we have height, we have lateral edges. Now, whereas in our cylinder and our cone, sorry, our cylinder and our prism, our lateral edges were pretty much right. Here, they're always going to be slanted. We also have something that's referred to as the slant height. The slant height is basically the distance from the edge of the base to the vertex. Why would the slant height be important? Well, in our shape like our cone here, that slant height is acting as the height of what shapes are on the side? Triangle. So that slant height is the height of the triangle. In our cone, goes down there real fast. We also have those same pieces. But then the slant height, all right, that's not the height of a triangle this time. That is important to us because if we were to unfold our cone, what shape do we have for those sides? Do you remember? We unfolded a cone. What's the side look like? Huh? It could be a semicircle, but it could be less than a semicircle and more than a semicircle. It was a sector. Now, that side length is important in that one because this side length is actually what for that circle? Yeah, it's the radius. So in here, these our equations use slant height in them because they're two very important measurements when it comes to a triangle and to a circle. All right, I'm going to show you a square pyramid. Now, just like our other formulas when it came to our prism, in our prism, our layer area, we looked at the side as one big rectangle, right? On here, we don't have a rectangle for the side, we have triangles for the sides. What's the formula for the triangle? For area of triangle? 1/2 base times height. Yeah. So we have on here, same idea for our lateral area, 1/2 base times height, but our base, just like in our other one, all the bases together here make up the perimeter of that base. So we're replacing the base with the perimeter of this base, but we're doing all the triangles at the same time. We're also replacing the height of the triangle with, that's the slant height of the figure. So on here, we're doing 1/2 BH, but you see where it says 1/2 PL, we just replaced the P for the B and the L for the H, because that's how they relate to the overall solid. Right? That's the same formula. Now, before I go any further here, let me go back to this paper from the other day. So, on this paper, we had perimeter. Sorry, already going down there. We had pyramids and cones, right? And again, we have equations that are very similar. We have, sorry, not the one I wanted to actually highlight there. This one and this one. So on here, these two equations, the first one has perimeter, the second one has circumference. But essentially, they are the same equation again. Same equation, we're just replacing the perimeter with the circumference. Same thing here. These two equations are the same. We have one base and we have the lateral area. For our volume, which we'll be talking about tomorrow for these two shapes, again, they are also the same. In their most basic form, the equations are the same. These two shapes are related closely, just like our cylinder and a prism were related closely. The basic equations for those two are the same, and the basic equations for these two are the same. Do they change as you add in other parts of the formula? Yes, because our cone, for example, will always have circles. So you'll notice if I plug in equations for circles, my equation changes. It takes on a different form because I can plug the equations in, I can simplify it, it gives me a different format at the end. Same thing for this one. Gives me a different format at the end because I know that my shape will always be that same shape of a circle. So we can simplify and always use that format. But if you don't know the final version there, you can always use the original format and just plug it in one equation at a time. And it will always work. No? Huh? Yeah, but maybe it's just because I'm saying next to the board. All right. So we got all the parts. Again, I highly recommend using this sheet as a reference as we go through this section because again, all the formulas are there if you want to use them from there. Okay, so going back over to that other sheet, let's do some examples. All right. I'm not giving you a huge homework assignment tonight. I'm going to do 2 examples with you right now, and then 2 examples on the other page, which means that there's only 2 more problems on each page. So your assignment tonight is going to be turning in these 8 problems on this page. But again, it's not going to be a lot of work because we're going to do 4 of them right now, and then you'll have the other 4. So on number 1, now one thing that's important here, up here in the little information, it says that each one of these is a regular pyramid. What does that mean? What do you think that means? Okay, so it does have something to do with all sides are equal. Now, what sides? Because can a pyramid be a regular polygon? There's only one such pyramid that could be a regular polygon, and that's a triangular, a very specific triangular pyramid called a tetrahedron. None of these are tetrahedrons. So what does that mean by saying regular pyramid? That means that the base on here is going to be regular, just like we name all of our pyramids by whatever the base is, triangular pyramid, square pyramid. It's just saying that each one of these is a regular pyramid, meaning that the bases are regular shapes. So all the sides are the same. On the first one, they labeled it so that we knew all the bases were the same. The rest of these, they didn't label them. So they said regular pyramid so that we knew that in each one of these, we had all the sides on the base were congruent. All right. Moving on, number 1. We have a triangular pyramid. We need to find 2 things, lateral area and surface area. First, let's do lateral area. If we do lateral area on this one, our formula again is 1/2 E L. L is the letter that we use for slant height. All right, and talk about it a little bit at the top. I think I forgot to mention it as we're going through it, but L is our slant height. So on here, when I look at this, what pieces do I have so far? Well, 20. That is my slant height. The 15, that's not my perimeter of the base, but it's going to help me find the perimeter of the base. What is the perimeter of the base? I got 15 for each side, so that's a total of what if I have 3 times? 45. So I have my slant height, I have my perimeter. That's all I need for this first formula. So 1/2 perimeter 45, slant height 20, and multiply that. Again, it doesn't matter the order you multiply, make it easier on yourself. Half of 20 gives you 10, and then 10 times 45 is 450. This is area, so it is units squared. Then we need surface area. Well, surface area uses our lateral area plus, now it's no longer 2 times the base area because there's not 2 bases. It's just the base area. So we already found lateral area. We still need to find a base area. Well, what shape is our base? Triangle. What type of triangle specifically? It is a regular triangle, which makes it equilateral and equal angle. So I'm going to draw it over here. 15, 15, and 15 are my sides on that base. Right? I need to find the area of that triangle. There are 3 different formulas that I can use. I know that all these are regular polygons for the bases because it says they are regular pyramids. So I could use 1/2 ASN or 1/2 AP. Or this is a triangle, so I have 2 other formulas I could use for a triangle. What's one of those formulas? What was it? 1/2 base times height works. All right. And then the other one is if you have 2 sides and an include angle, you could use that one, which is 1/2 AB sine C. Any of those 3 work here? Which one do you want? Half base times height. All right, we can do that. So for my base area, I'm going to do 1/2 base times height. Well, if I do 1/2 base times height, I have a base. 15. Do I have the height? No. So I need to find that height. Well, in a regular triangle or an equilateral triangle, all the angles are 60. So this is actually a 30, 60, 90 triangle. So since that is a 30, 60, 90 triangle, what's the height going to be? Anybody know? What am I looking at? What was it? Close. It's not 15 radically though. Well, you have to do this bottom number first. This is our short leg. It's only half of that 15. So this is going to be 7.5. So let's try to get what's the long leg? Well, not 15 radically, but short leg times radically. 7.5 radically. So my formula here, 1/2 the base times, again, in our special right triangle. So again, when I split that in half there, this is my hypotenuse, this is my short leg, that's my long leg. Everything's based on the short leg. The short leg and the long leg, the short leg and the hypotenuse are related because the hypotenuse is double the short leg, or I can say the short leg is half the hypotenuse. Then the long leg is the short leg times square root of 3. So again, I mean this is 15, half that's 7.5, multiply that by square root of 3, and that's my value there. We can plug that into our calculator. And when I plug that into the calculator, 0.5 times 15 times 7.5 times square root of 3. 7.4278. Now, you can select your decimals. All right. Do I really have to at this point? No, I'm just going to add this one other number to it. But again, they could make a difference on some of these problems. So on here, plug that in. We have ladder area was 450. The base area, which we just found, 97.4. So our total here that's our surface area, 547.4. And yes, it's in cubic centimeters. All right, number two. On a lot of these, they don't give you the slant height. So on number two, the only thing they gave us was the height of the pyramid. That's it. There's a lot of information missing. We don't know the perimeter, we don't know the slant height, but can we find it? So, what other piece of information they give us besides the height? They did give us something else. Height was the only dimension they gave us, but they did say one other thing. What else do we know about figure two? This triangle here. It says this is the right angle, and that's a 45-degree angle. So that's enough to find some other sides of that triangle, because that is a 45, 45, 90 triangle. If the height's 8, the other leg has to be 8, and the hypotenuse has to be what? What's the hypotenuse have to be? This is 8, and this is 8. This is 8. Radical 2. That's going to be our slant height. So we have that's 8. We have this piece here is 8. Yeah, that's 8 radical 2. We also need the length of this side. Well, we know from the center over is 8. So that should be 8 as well. So what's the entire side here? 16. So now we have all the information we need because all the sides are going to be the same. So we have our side length, so we can find our perimeter. We have the slant height. We have the length of the side, so we can use that to find the area of that base. So it should be good to plug into our equations now. 1/2 equals 1/2 perimeter times slant height. Perimeter on this one, if all 4 of those sides are 16, that would be 64 for my perimeter. Slant height, 8 radical 2. So now I'm just multiplying it out. So we have 1/2 4 times 8. $56. That's our answer as exact value, but it wants us to round our answers, so that's going to be 362.06. And rounding it off to 1 decimal place, it's just going to be 362. And this will be in feet squared. For surface area, again, we need that base area first. That's 16 times 16, which is 56 again. And now we have our base area, our surface area, just adding those two together. 2 plus 256. It's a total of 618. We have 2 more on that page. All right, let's take a look at the cone real quick. So again, on the cone, same thing. All right, our cone formula. You can use the basic cone formula, or if you're looking at this, you could use a simplified version, which is this pi RL for our lateral area. So we have pi, the radius 9, the slant height. Oh, we don't have a slant height. What's our slant height here? Yeah, what is our slant height? Well, 15. It's 15. That's at 3, 4, 5 again, but they've all been multiplied by 3. This is 9, 12, 15. Again, like I said, 3, 4, 5, and 5, 12, 13. Those come up all the time, and they're multiples. So they're a multiple of 3, 4, 5. So, could you use Pythagorean theorem? Yes. Again, will you waste a lot of time using Pythagorean theorem? Yes. So, again, try to know some of those triples. On here, multiplying that out. What's 9 times 15? It's 9 times 15. So we have 135 pi. They said round again. So 424.1. That's 424.1. Centimeters. Surface area. Again, I need my base. So what's the area of the base? IR squared. Radius was 9. 9 squared is 81. Now, most of the time, I find my surface area before I even multiply it out by pi. So I would have done 135 pi plus 81 pi. So what was that? 135 and 1 gave us 216. Yeah, 216 pi or 678. 6. That's it. Again, a lot of these problems, there's going to be something missing that's unique. Most of the time, it's going to be slant height, but it could be other things. So notice they're doing a lot of different things with triangles still. Here is a triple. There's a special right triangle. There's another special right triangle, and another triple. So on every single one of these problems on this page, you have to do something with those triangles in order to find a missing piece. So again, we'll keep using those. All right. You have a total of 5 problems there for your homework assignment. Again, just this side. If you want to do the other side, say you have a game or something tomorrow and you want to try and get the whole thing done tonight, great. You can. The other side is area. Sorry, not area. Volume. We haven't gone over volume for those 2 shapes yet, but if you want to use this and get a head start on it, the equations for volume are there. But for tonight, the only thing that is due is the 2 pages, 18 and 19.